I want that you imagine that you're a scientist, right? I want that you imagine that you're a scientist and you take some measurements of some values or magnitudes and you want to interpret your results. And now that we're talking about proportions, you would like to see if your results are according to a proportion. In this video, we're going to see how you can relate your values and how can you relate your results of an experiment using proportions. Okay, I want you to imagine that you have, for example, data from time and displacement, because you're measuring the motion of an object, and you find out these values, and these values are for some times 0.5, 1, 1.5, and you don't have the value of 2.0, but you want to see how is the pattern, and you want to identify how to name this pattern. So I want that you observe this table, and if you observe the table, you can see that if I take the rate of displacement to time, if we take the rate of displacement to time, I'm gonna get 6.0 centimeters over 0.5 seconds. Or in plain terms, it will be 6.0 divided 0.5 is 12 centimeters per second. But then you said, okay, but what happened to the rate of the second line, of the second measurement? What will be the rate of 12 centimeters to 1 centimeter? To 1 second. It's gonna get you 12 centimeters per second. And then you observe that for the next value, you get 18 centimeters over 1.5 seconds. It's going to be 12 centimeters per second. So look at that, in this relation that we have between two data, between two things that we're measuring, between two magnitudes that we're measuring, we have something in common, and is that the rate is the same. So we have a common rate. So every time you have a common rate, there's a relation between these magnitudes, and this is when you can tell that we're doing directly proportional magnitudes. So you have directly proportional magnitudes when the rate between those magnitudes, it's going to be a constant. So you have a common rate. If you have a common rate, you will have a directly proportional magnitudes. This is something that it's amazing, because it's the first thing in which you can see the relation between proportions, that it may be something about pre-algebra, with magnitudes and relations, that it's more like a function analysis and algebra. But let's see something extra that has directly proportional magnitudes. Look at that. I can see here in my example that this common ratio 12 could multiply the time to get the displacement. So if you take 0.5 seconds times our common rate 12, I'm gonna get 6. If you take 1 times 12, I'm gonna get 12. If you get 1.5 times 12, you're gonna get 18. So look at that, what you're doing is multiplying the independent variable, the variable that you can know the values, to get the dependent variable, the variable in which you don't have the values and maybe you want to predict. So look at that, for example, you can predict the value for 2. You can predict the value for 2 because you can only multiply times 12 to get 24 0.0. Look at that, I'm keeping the same amount of significant figures or the number of decimal places here. And this is something amazing because you can now predict if you see the trend, the pattern. And here the pattern is that you need a common rate. This is how you can get information from independent variables. For example, you can say here, maybe you want to include here the fact that the displacement is equal to 12 centimeters per second times the time. And we call this C, that we say the common rate, this is something that we call the constant of proportionality. And this is why this is related with proportions. Look at that here, I'm using common rates, and using common rates means a proportion. Remember that a proportion is a common rate. This is how you can interpret directly proportional magnitudes. And let me include something. What will happen if you do the graph of displacement and time? I recommend you that take a grid paper and do the graph of this table. And see what's going to happen to your graph. If the magnitudes are directly proportional, you're going to observe that your graph should be a straight line that crosses by the origin of the coordinate system. And this is how you can have directly proportional magnitudes. So remember, some things about directly proportional magnitudes. First, you have directly proportional magnitudes if the rate of the magnitudes is a constant. Second, you can predict the value of the independent variable if they are directly proportional by multiplying the independent by the common rate or the constant of proportionality. And third, the graph of two directly proportional magnitudes is a straight line that crosses by the origin. I hope that you enjoyed this video. I hope that you like it, because in the next video we're going to talk of the other relation that is about proportionality, inversely proportional. So I hope you have a nice day and see you soon. Bye bye.